last day with Chapter 7.7 of Composite Functions. Today we're going to be talking about evaluating composite functions. Okay, so yesterday we learned a little bit about evaluating with relations, where we had an input, got our output, plugged that output into the other input, and then got our output. Okay, so today we're going to be doing it with functions where our domain and range are now infinite number of points instead of just ordered pairs. Okay? There are two ways that you can evaluate a composite function. Okay, and I will show you both, and then we will do both, and then we'll be done. Okay? So, if f of x equals x plus 3 and g of x equals x squared plus x minus 1, find f of g of 2. Okay, so we're going to composite the functions f of g, and then we're going to evaluate it at 2. Okay, the first option is to actually composite the functions first. Excuse me. So we know that f of g of x is written like this, so we know that g of x is our input into the function x. So we're going to take this g of x and put it where this x is over here. So we take this x squared plus 1, put it right here, and then we have this plus 3. You might recognize these f and g's from 2 days ago. Okay? Simplify by combining like terms, and we get x squared plus x plus 2. Okay? Once you composite the functions, then you can just evaluate. So if we know we're evaluating at 2, then we just put a 2 wherever x is, and then simplify. 2 squared is 4 plus 2 plus 2 is 8. Okay? So you composite first and then evaluate. Okay, our other option is to evaluate in two parts. Okay? If we look at this in terms of how we did yesterday, where we had our input of g and our output of g, and then the output of g became the input of f, and then we got our output of f, we can do that same process here. So we know that f of g of 2 is written like this. So going with the order of operations, we'll work the inside out, get parentheses first. We can just evaluate g of 2 first, which we know how to do that. We can either use synthetic substitution, or we can use just regular substitution, which I used regular substitution here. So if we're calculating g of 2, we take our g of x and put a 2 wherever we see an x. So we'll have 2 squared, which is 4, plus 2 minus 1, and that gives us 5. Okay, then we see here that we're plugging in our g of 2 into our f. So we're taking f of g of 2. Well, we know that our g of 2 equals 5. So we can replace that g of 2 with 5 because that's its value, and now we're just calculating f of 5. So now if we put in 5 where we have our x over here, we get 5 plus 3, and that's 8. Okay? Two ways. You can pick your favorites. Let's try this on our own. Okay. So, if f of x equals 3x squared minus x plus 4, and g of x equals 2x minus 1, find g of f of negative 2. Okay, so option 1 was to composite the functions first. So if we do that, we're going to have g of f of x. Okay, that means that I'm taking my f function and I'm putting it wherever I have an x over here. Okay, so that means that I'm going to have 2 times my f of x minus 1, because this is my x, so I'm putting it wherever I see that x. Okay? So that means I'm going to have 2 times f of x is 3x squared minus x plus 4 minus 1. Wobbly. Okay, I distribute, which gives me 6x squared minus 2x plus 8 minus 1. Combine like terms, I get 6x squared minus 2x plus 7. Okay, so now if I evaluate g of f of negative 2, ooh, bad handwriting, oops, of negative 2, that means I put in negative 2 wherever I see an x. So I'm going to have 6 negative 2 squared minus 2 times negative 2 plus 7. Negative 2 squared, negative 2 times negative 2 is 4. 4 times 6 is 24. Negative 2 times negative 2 makes us positive 4 plus 7, which is going to give me 35. Okay? That's option 1. Composite the functions first, which is what we learned 2 days ago, and then just plug and chug. Okay? Or we can do option 2. Okay, so if we're finding g of f of negative 2, g of f of negative 2. My first step is going to be to calculate f of negative 2. So, f of negative 2, I'm going to put a negative 2 wherever I see an x. So I'm going to have 3 negative 2 squared minus a negative 2, don't lose that negative, plus 4. Negative 2 squared is 4, times 3 is 12, minus a negative 2 makes that a plus 2, plus 4, which equals 18. Okay, now that I've found f of negative 2, g of f of negative 2 equals g of 18, which g of 18 is going to be 2 times 18 minus 1, which is 36 minus 1, which is 35. Okay, either way you get the same answer. Whichever you prefer, whether you want to evaluate twice or composite and then evaluate, is up to you. As long as you do the math right, you'll get the right answer.